We like to think reality is logical. Cause leads to effect. Up is not down. Time moves forward. But peel back the surface of our universe, and logic begins to crumble. Paradoxes, those strange contradictions that shouldn't make sense but somehow exist, are the very foundations of our reality. Let's start with Zeno's paradox. He said, "Motion is impossible." Sounds absurd, right? But imagine this. To walk across a room, you must first walk halfway, then half of the remaining distance, then half of that, and so on, forever. You're stuck taking infinite steps in finite space. So, how do we ever move? Turns out this ancient Greek brain twister wasn't wrong, just incomplete. Centuries later, calculus would reveal that infinite steps can add up to a finite distance. But until then, Zeno froze motion with pure logic. And he wasn't alone. Next up, the grandfather paradox. You build a time machine. You go back in time and accidentally prevent your grandfather from meeting your grandmother. So, you're never born. But wait, if you were never born, how did you go back in time? This paradox isn't just science fiction. It haunts real physics. If time travel is mathematically possible under general relativity, how do we avoid unraveling reality? Some say the timeline fixes itself. Others suggest multiverses. Every change spawns a new reality. But nobody has cracked the code. Now shift gears to Schrödinger's cat. A cat is placed in a box with a vial of poison, triggered by a quantum event. Until you open the box, the cat is both dead and alive. This isn't metaphor. Quantum mechanics says particles can exist in multiple states at once, called superposition. And it's only observation that collapses reality into one outcome. So, is the cat watching you? We live in a world where your phone depends on this paradox. Quantum weirdness powers lasers, GPS, semiconductors, core tech in our lives. Paradox built the future. Let's talk the bootstrap paradox. You find a book. It contains revolutionary knowledge. You publish it. Years later, someone travels back in time and gives it to you. It's the same book. Who wrote it? This paradox raises questions about information loops, authorship, and causality. It challenges our most basic assumptions, that everything must have an origin. What if some ideas exist in a loop without a beginning? And then there's the Fermi Paradox. With billions of stars and even more planets, where is everyone? Statistically, the universe should be teeming with life. But all we hear is silence. Some say civilizations destroy themselves. Others believe we're in a galactic zoo, watched but untouched. Or worse, we're truly alone. This paradox haunts our understanding of life itself. And it's not just about aliens, it's about our place in the cosmos. What if we're early? What if we're the last? Paradoxes aren't errors. They're pressure points, places where our understanding fractures. They're invitations to look deeper. This isn't just abstract philosophy. It impacts how we see time, space, and even consciousness. Reality, as we experience it, often runs counter to what logic or math suggests should be possible. In chasing answers, we often discover deeper questions, questions that may never be resolved. Every step forward in science seems to uncover another contradiction we must learn to live with. Our universe doesn't always play by the rules, and sometimes it writes new ones just to confuse us. These paradoxes are more than puzzles. They're clues to the deeper structure of reality itself. The more we understand, the more we realize we might be asking the wrong questions. At the heart of every paradox is an invitation to rethink everything we take for granted. Philosophers and physicists alike have tried to crack these contradictions for centuries. What if the contradictions aren't flaws, but features, baked into the universe's operating system? We chase certainty. But reality? It was built on uncertainty.